So we're going to start with this concept of a Newman projection. A Newman projection, we're going to have this eye right here. So you can pretend this is your eye and give it some eyelashes. Now we have this eye and we're looking into a molecule. This molecule has a carbon, another carbon, bonded together by 2 electrons. And each of these carbons have to have individually 1, 2, 3 more elements or groups of molecules attached to the core right here. So with this carbon here, we would have a hydrogen group attached that's within the same plane as these other carbon molecules, carbon elements. Now, we're going to need another molecule to be facing outward. So this bond right here, this represents a molecule or an element that's attached to the carbon that's facing outwards towards us. And we can say that that is a hydrogen, and then we're going to have another attachment, but this one's going to be facing away towards the back. And we're going to represent that with this type of drawing. And we're going to say that is a CH3 group. Okay? Now, this carbon here also needs 3 different things attached to it. So we're going to go ahead and draw something attached to it. We're going to have a hydrogen attached to it. And we're going to say that there's a CH3 group actually coming away towards us. Not coming away, coming towards us right here. And then lastly, we're going to have our hydrogen group out towards the back. Now, in this visual space, you're looking straight at the center right here. So when you look at the center, you actually only see this carbon molecule. We're going to go ahead and draw what that would look like. So from our view, we would, if we were right here where the eye is, we would be looking straight at the center right here. And this would essentially indicate that that's our central carbon right here. This carbon here, we won't see that carbon. We will be able to represent these groups here in our image, our Newman projection. However, we won't be able to see this actual carbon in this bond right here. So bonded to this, let's say that this is the right hand side right here is going to be facing towards us here. So this CH3 group that's attached to this carbon, to our first carbon, is going to be right here on the right. So CH3. This hydrogen group that's facing towards the back is going to be represented right here to our left. And lastly, this hydrogen group is going to be represented up here with this bond right here. Now, how do we actually represent these groups right here? Well, we're actually going to go ahead and draw in a circle right here. And that's essentially going to show us that we're going to have these groups coming out, right? So this group that's coming towards us, this hydrogen group, is going to be towards the right, as we indicated earlier, right? This CH3 group, which is going away from us towards the back, is going to be on the left-hand side, since the previous hydrogen group that was going towards the back also was on the left-hand side. So this one's going to be represented right here, CH3 group, and that's actually all you need to do for the CH3 group. You can feel free to go ahead and write CH3 if that helps, but you really only need to show that it's a CH3 group on the outside, so you would only really need to draw the stick right here. And then lastly, we have this hydrogen group. And this hydrogen group actually should have been drawn going downwards this way on the plane. It should have been a dash going straight down. So that was my mistake, but we're going to go ahead and represent it right here correctly. And this is what we call a Newman projection. I'm going to go ahead and be doing a couple more videos that feature these Newman projections to really help you grasp the concepts, because these will be these give you a good spatial representation of where each group is in terms of space, in the space of the bonds, in the space of the actual molecule. So more videos to come. Thank you for watching.